Not surprisingly, a text file contains text. That text is a stream of characters, and those characters can be encoded in one of many possible encoding schemes. We talked about the ASCII encoding scheme last week, but there are other schemes that can represent far more characters. The good news is we don't have to worry about the encoding or decoding of any of them. MATLAB takes care of all of that for us. One difference relative to the files we've used so far, that is Excel files and MAT files, is that before we can use a text file, we have to ask the operating system for permission. Making this request is called opening the file, and MATLAB did it behind the scenes for us for Excel and MAT files. Then once we're done with the file, we have to release it, which is called closing the file. So how do we do this opening and closing? Well, we use built-in functions, starting with fopen. As you can see, fopen takes two input arguments, a file name and a permission, and it returns one output, a unique number called a file identifier that we'll need in order to read from the file or write to it. When it's time to close the file, we'll use another built-in function called fclose. It takes one argument, which is the same file identifier that we got from fopen. For fopen, the first input argument is exactly what you'd expect, a string containing the name of the file. The second argument is also a string, and it specifies what we're asking permission to do with the file. Do we want to read, or write, or both? If we want to write, do we want to discard the current content or append text to the end of the file? Well, here are our options. As you can see, they all include the character T. This T tells MATLAB that the file we want to use is a text file. R stands for reading, W stands for writing after discarding the current contents, and A stands for appending. The plus sign means we plan to do both read and write. You can see all the combinations in this table, and you can get the same list with the command help fopen. Now let's do some work with text files. Here's a function that we've prepared for you called write temp precip text. It writes data into a text file. It's not too big. Scroll down here just a little bit. See there's just a few lines missing. In fact, if we close the ribbon up here by clicking right here, we can see all of it. Let's try it. I'm going to hit Tab at this point. There, it gives me the options. If I double click that one, it completes it for me. For lazy people like me, it's very handy. Well, I'm going to use this function to write precipitation data that's stored in the function into a file called climate.txt. Here goes. If we look over here, we see the file appear, climate.txt. And if we click right on it here, open it outside MATLAB, we see it in this text reader that the Mac provides us. You see climate data for Nashville, Tennessee, which came from here, and average highs and lows and so on. All these nice labels all laid out here. All the numbers show up over here. It looks really nice. Let's look at this function to see what it takes to write a text file like this. The first few lines provide just a bunch of string variables that contain the various labels. And of these, the two most interesting ones are the last two right here, mo1 and mo2, because they're cell variables. You see these braces over on the right, which means that these strings, each one of these strings, is stored in the memory, and the address of each one of them shows up as elements in this array, mo_1. And we learned the reason for using cell arrays back in lesson 7. When you have a bunch of strings and they're different lengths and you want to store them in a single array, really the best way to do that is with a cell array. The next two variables we create in the function are for the actual climate data, data1, data2. We create two matrices, here and here, for storing the temperature and the precipitation data for the various months. The reason we have two matrices and two cell arrays is simple. There are two separate sections for the first and second halves of the year, here and here. So it's easier to have the corresponding data in separate variables. Once we have the variables set up out of the way, we can start dealing with the text file we want to create. The fopen function tries to open the file using the name that was passed to it by the caller of the function. That's called file name. The W+T argument, as we've seen before, tells fopen that we want to write this file, and if it doesn't exist, we want to create it. If it does exist, we want to discard its current contents. This T here says that it's a text file. The function returns a number. If it successfully opens the file according to our request, then the number is positive. And we call it the file ID or file handle. And it's stored in FID here. However, if it failed to open the file for any reason, for example, if we don't have write permission in the current folder, it'll return a negative number. In that case, we print an error message and immediately return from the function. This guarantees that the code after the if statement will execute only if we have a valid file open and it's ready to be written. Then comes a sequence of fprintf functions. This is the familiar fprintf function that we've gotten used to before, but this time the first argument is a number instead of a string. In that case, MATLAB will write the output from fprintf into the file that has that file number, that file ID, that handle, instead of writing it to the command window over here. It's that easy to write text into a file. The first few printfs write the title and the column headers into the file. Then it's time to write the data into the file. That's done in this for loop and this for loop. The good news is that we know all of this stuff already. The format string for fprintf works the same way as before when we were printing to the command window. Cell arrays are accessed using these braces just as we learned before. All the things that we're doing here are things that we've learned to do earlier. Once we're done with writing, we need to remember to close the file, and that's done right here with fclose. That's it, we're done. Now you know how to write text files from a MATLAB program. A text file is usually broken into lines so humans can read it easily, and they read it one line at a time. Well, that's also the best way to read it with a computer. We'll illustrate that by writing our own version of the built-in function type. Type reads and prints each line of a text file to the command window. Let's re-implement that function by reading a text file one line at a time and printing each line to the command window immediately after we read it. Our view text file function takes the file name as input and returns no outputs. It just simply reads and prints the contents of the file one line at a time. First, we need to open the file, and we open it for reading with the fopen function using a permission RT, which means read text file. We should always check that the file open request was successful, and we do that by checking whether the file identifier returned by fopen is negative. If it is, then there was a problem opening the file. The file may not exist, or some other program may be using it, or we don't have read access to the current folder. In that case, we call the error function, and our function will close. But if it's non-negative, we have a valid file identifier and we're in business. So we're ready to read the contents of the file. To read the first line from the file, we use the built-in function fgets. We give it the file identifier and it reads one line and returns that single line in a string. Here we catch that string in a variable named oneLine. We use a while loop to print the current line and then read the next line repeatedly until we reach the end of the file. And how do we know we've reached the end? Well, that's a little tricky, but fgetS helps us out. When fgetS reaches the end of the file, there's nothing left to read, so there's no string to return. Instead, it returns a -1. So we use the isChar function in the condition of the while loop. IsChar returns true only if its argument is a string. If it returns false, then we've reached the end of the file and the while loop will quit. Inside the loop, we use fprintf with the %s format specifier to print the current line, which is stored in one line. Then we use fgetS to get the next line, and so on. Pretty simple, really. Finally, we put an extra new line character to make sure that after the printing is done, the command prompt will appear on a new line. Then we close the file. That's it. Not too bad, was it? Yeah, reading strings from a text file is easy, but converting those strings into numerical data is much harder. For example, if our climate data spreadsheet were a text file instead of an Excel file, it'd be a painful process to write the code necessary to recognize the digits and decimal points that represent temperatures and precipitation data and convert them into numerical values inside variables. The textbook describes how to do it in detail, but it's cumbersome. And while text files are nice for humans to read, they're a poor way to store numerical data. Furthermore, converting text to numbers is not a fundamental issue in learning the program, so for all these reasons, we're not going to cover it in this course. Instead, we'll show you how to read and write numbers with binary files, which are much more suitable for this sort of thing.